Hey everybody, Dr. A here, and in this video we are going to be explaining and going over the addition method for solving systems of equations. Now the addition method, some people call it the addition method, some people call it the elimination method. So, but it means the same thing. So if you ever hear the term addition method or you hear the term elimination method, it just means the same thing. Some people even just call it the addition elimination method. The reason why it's called these two different names, but it's the same process, is because in this method, what we do is when we have a system of equations, or we have sometimes called simultaneous equations, what we do is we eliminate one of the variables in one of the equations by adding a multiple of the other equation to it. Okay, so that's basically the whole premise of it. So let's write that down. In this method, we add a multiple of one equation in the system to another equation in the system in order to cancel one of the variables. Then we can easily solve for the other variable or variables. Okay, so again, we are adding a multiple of one equation to another equation in the system in order to create a cancellation, or in other words, in order to eliminate one of the variables. So instead of cancel here, you could put in parentheses eliminate. So there's the term elimination method. And then after we have eliminated one of the variables in the system, we can easily solve for the remaining variable or variables. Okay, so this method works pretty well for systems of two equations with two variables. You can also use it for larger systems like three equations with three variables, but it does start becoming a little tedious and inconvenient once you have larger systems with like three equations, three variables, or four equations and four variables. So we see it more often with two equations and two variables, okay? Another interesting thing about this method is sometimes this method is used with the substitution method. So sometimes you can kind of combine some steps from this addition method with substitution method. Okay, so let's jump right into a quick first example of this. Okay, so in this example, call this maybe example 1, and we're going to be given some information here. Our given information is to use the addition method to solve the system. All right, and again, you could also call this the elimination method. It doesn't really matter what you call it. So here's our given system: 2x plus y equals 9, and then we have 3x minus y equals 16. Okay, so here we have two equations with two variables. So it's a system of simultaneous equations, and we can call this equation 1 and equation 2. You know, from my other videos, I like to label my equations just to help me stay organized. So I'm going to write solution here. And so in order to use this addition method, or otherwise called elimination method, we want to add a multiple of one of the equations to the other equation in order to create a convenient elimination of one of the variables, okay? And it really doesn't matter which equation you add to the other to eliminate a variable, okay? You can write these equations in any order. You don't have to write them necessarily in this particular order. You could, write equation 2 on top of equation 1. It won't matter. It won't change anything. So at first glance, you may notice we can directly add these equations together to create a convenient cancellation of y. So this happens to be a pretty easy first example. So we can say we can add the like terms, quote, vertically to cancel y or eliminate y and solve for x. Okay, so watch what I'm going to do here. I'm going to rewrite this system 2x plus y equals 9. And I'm going to write 3x minus y equals 16. And the reason why I say this step is pretty convenient is because notice that in terms of the variables y, they're already an easy multiple of one another. It's a multiple of 1, and one of them's positive and one of them's negative. So we can, add these two together in a stacking fashion, and we will end up with 5x, and then notice that the y's cancel. So these kind of cancel downwards, and then you get 9 plus 16 is 25, and you end up with x equals 5. That's part of your answer, okay? So that's an easy addition / elimination step to solve for x. Now let's do another elimination step with the original system and solve for y this time, okay? So how about this? How about we, now we're going to say, now let's solve for y using the same method. Okay, so I'm going to rewrite these equations, okay? Original equations, 2x plus y equals 9, and then I've got 3x minus y equals 16, okay? Now again, we have x equals 5. That's part of our solution. What we want to do now is, again, find a way to create a convenient cancellation of the x variable so we can solve for y here. Now, how do we create a convenient cancellation with the x variable? It's kind of tough right now because you have a 2x in the first equation and a 3x in the second equation. You can't just add them up. You'll accidentally come to a 5x conclusion again. So here's where we can go back to the general process. I'm going to scroll back up and I'm going to reread what we wrote to begin with. We can add a multiple of one equation in the system to the other in order to eliminate one of the variables. So how about this? How about we create a multiple of one of these equations? So I'm going to make a little note here. I'm going to say create a convenient multiple of one of the equations. Let's use equation 1 right now. Watch this. I can multiply both sides of equation 1 by a non-zero constant, and that will allow me to come up with a creative way to cancel x. How about we use a non-zero constant of -3/2? So watch this. Let's multiply equation 1 by -3/2. Watch what happens when I do that. I'm going to say -3/2, and then I'm going to say open parentheses, 2x plus y, close parentheses, equals, and it's still an equation. What you do on one side of the equation, you have to do on the other. So I'm going to multiply both sides of this equation by -3/2, all right? And and when I do that, if I distribute that 3/2 on the left side, I'm going to end up with -3x minus 3/2 y equals negative 27 over 2. Now, you may be looking at this and you may be thinking, wow, Dr. A just made equation 1 more complicated. Well, maybe at first glance that's what it seems like, but watch what I can do now. Now I can restack my new version of equation 1. Here it is. Above my original version of equation 2, which was 3x minus y equals 16. Now look at this. Now I can add these two equations together. And where is there a nice convenient cancellation here? Well, on the x variable, okay? And then once I add the y terms vertically, I'll get negative 5/2 y. And then on the right side of the equation, I will get a 5 over 2. And then suddenly I have the solution y equals negative 1, of course, because the negative 5/2 cancels with a positive 5/2, and you're left with y equals negative 1. So the solution to the system is the following. The solution is x equals, what did we get for x? Already forgot, 5. X equals 5 and y equals negative 1. Now, a couple of little comments, okay? How did I know to come up with this negative 3/2? How did I make that up? No, I didn't really make it up. You just have to kind of think, what can you multiply by one equation in order to cancel one of the terms in the other equation? So when I asked myself that, I said, well, if I multiply equation 1 by negative 3/2, then the 2 in front of the x term will cancel, and a negative 3 will get multiplied into the x term. That's where I came out with this negative 3x. And then I'll be able to add these two equations together such that the negative 3x will cancel out with the positive 3x from equation 2. So here's a little note to yourself to help you out, okay? Ask yourself, what can I multiply one equation by in order to cancel a variable in the other equation, okay? And sometimes that may be a fraction you've got to deal with. I know some people are not big fans of fractions, but that you got to deal with them sometimes, okay? So that concludes this first quick example of the addition, or also called the elimination method. Thanks for watching.